So now we'll use this result with our particular set of equations that we're using now. So then dy dx is dy dt, which is negative sine of t, right? Derivative of cosine is negative sine, over 2 cosine 2t, because that's using chain rule on sine of 2t. All right, so then now this kind of notation is really useful because I have dy dx, but I'm evaluating it at a variable that is not either of those variables. So it's nice for me to be able to write dy dx evaluated when t equals 0.6 of negative sine 0.6 over 2 cosine of 1.2 because it's 2x, so that's 1.2. It's easy to read, I'm sure. All right, so I did that on my calculator already. I got negative 0.779. So what can I do with that? Well, I should be able to write the equation of the tangent at that point. So I need to know also x and y of 0.6. So I need x of 0.6 and y of 0.6. And I probably still have those in my table, right? Hopefully this is still my table from before. Yeah, 0.6. Looks like I have 0.932, 0.825. All right, so 0.932 equals 0.932, and then my y of x is 0.825. So I could write the equation of the tangent as y minus 0.825 equals negative 0.779, x minus 0.932. All right, so that's equation of the tangent. Equation of tangent. Well, let me write that down here. Equation of tangent. Right, that's what I can do once we can be able to find dy dx, so we can get what the slope of the tangent is, and then we can use x and y at that particular value as y1 and x1, y1 and x1 in that formula. Let's see, could we sketch that by hand? Because actually, it's not so hard to sketch that by hand on our sketch, and actually I want you to include this on your sketch, because I know that when I plotted these points, this was t equals 0, t equals 0.3, and t equals 0.6. So the t equals 0.6, that right there, that is this point right here, 0.825, 0.932, 0.825, that's this point. So all I have to do is make a slope of negative 0.779. Well, that slope, which is equal to negative 0.779, well, that's kind of close to negative 0.8, isn't it, right? Which is negative 4/5. So what I could do is I could do my rise over run, go down 4 and over 5 from that point. So if I go from this point down, so I have to be careful because it's sort of in the middle, 1, 2, 3, 4, and then over 5, so it'd be like 1, 2, 3, 4, 5, and try to sort of get it, you know, in the right place considering that. And then see, I can draw that point, that line, and it looks like a pretty good tangent line actually. Looks like a pretty good tangent line for that point. Maybe it's a little hard to tell because of the way that graph is sketched. But you know who's really good at making graphs? Your calculator. Now here's the problem with your TI graphing this line is that your TI does not like to mix types of problems. So we're in parametric mode. We would have to get this line to be in parametric mode also, right? So I could rewrite that as y equals negative 0.779, x minus 0.932 plus 0.825, right? So, but I'm in parametric mode, so how am I going to write that in there? Well, what I do is I'll have x just be t, and then I'll have y be negative 0.779 times x minus, or is really t minus, 0.932, and then plus 0.825. Flying without a net right now. I haven't tried this yet. Hopefully it'll work. Let's graph it. Oh, look at that nice tangent. Yeah, and it only graphed. So you didn't graph the whole line because there's a limitation on what your what the t was. So if I change the t to be like negative 100 to 100, I would see the whole line. So there you go. You can actually do these in Desmos as well. Maybe I'll look at one of those in our next video.